So now we will begin our first facilitated discussion. So this discussion will be generally about climate and drought, and we'll address some of the questions that both Simon, David, and Justin brought up in some of their work within these questions. Just to set a few ground rules for this discussion, I really want this to be an open discussion. We've created a Google document that Roger will bring up on the screen here that has a series of questions to help guide the discussion. If any of you have brought tablets or anything like that with you, you can access that document and type in responses, and those will be up on the screen for everyone to see and can help spur the conversation. We are recording this meeting, so one thing that I would like everyone to do is there'll be 3 microphones that are scattered around the room, and to use a microphone when you'd like to speak, and also state your name and the organization that you work for. So with that, we will start our discussion. The first question that is related to both of the talks that we had here is, what climate uncertainties do you face in your water system, management, operation, or planning? Of some of the climate concerns that we've talked about, what are the issues with climate that you are most concerned about? And when someone would like to respond, I will moderate, and just raise your hand just so we can keep this relatively orderly. But if someone has a comment and someone else would like to address that comment or concern they have, please feel free to do that. So in your work, what climate uncertainties are most important to you? What are you most concerned about? Go ahead.
I don't have a mic, but a consistent message.
And if you could state your name, Bob.
My name's Bob Fotheringham, and one concern I have is the consistent message that goes out to the public and how they perceive climate change. The perception's changed over time, but people in Utah do not, I believe, have a constant reception of the information. I mean, it seems like, anyway, that's the bottom line. How the public perceives this and the message that's put forward so that they can resolve issues that they have in their minds.
Do you think the issue is more talking about getting people to understand that climate change is real, or is talking about, as we sometimes do in these settings, talk about variability in climate, say with some of the tree ring work of looking to the past where there have been droughts of record that are much greater than we've seen in our historical record? Do you think the best way to approach this is really talking about climate change and that this is a real phenomenon that we need to address, or is it better served to talk about climate variability when you're talking about with public perception?
Well, an example I could use is there was an article in the Deseret News fairly recently about research that was done at the University of Utah, and that research indicated some outcomes, but those outcomes aren't really pushed by the group who's studying the environment, because there's a huge change in how they're going to have to perceive what's going to happen to have water supplies meet in the future. And I think Dave Rosenberg's proposal to study how the systems work all the way along the Wasatch Front is very important to understanding what's going to happen in the future. But bottom line is there's not a consistent message from the group who are studying this. The message I read in the article was it's going to be flashier. You hear Robert Gillies say that we're receiving more precip, but it's coming as rain. Yet in that article it says that we need more storage and more of it. Yet the people who are studying this don't really want to accept that, it seems like. We're trying to come up with a different answer, and the answer seems to stay consistent. But how are we gonna manage it?
That's a very good question. That's one of the challenges we all face.
I'm Chris Pangra, mayor of Eagle Mountain. I think by and large the issue of water use and water management and climate change, it's been entirely politicized. So it's become an issue of when we talk about climate change, people become much more concerned with the stated reason for climate change or climate variability. Whatever you want to call it, it's really of no consequence. The fact is we have to deal with reality. And somehow we have to get people off of that politicized conversation and just recognize that, over time, there's plenty of evidence to suggest that the climate does not stay exactly the same decade after decade. It does change, and that's just reality. Whether that's man-made or just natural cycles, does it really matter? And I think the answer is clearly no, because we're still going to have to deal with the impacts of that climate change. And so I think as far as dealing with the public, I think it's up to politicians. Probably I'm the only one in the room, I'm guessing, but probably up to politicians to stop politicizing these fundamental problems that we're all dealing with and just get to the heart of the issue. And I think that's what has to happen. And I think the people with the technical expertise have the data necessary to be sharing that with the policymakers of today. And I don't know what the best way to do that is, but certainly the folks here at USU and Seawell have gotten my attention, which is why I'm here. But with that, if I may, just to come back to your question, is what climate uncertainties do you currently face in your water system management, operation, and/or planning? For me, we're off the Wasatch Front, so to speak, by a little ways, and we have seemingly a very different climate, microclimate in our area. And for us, we really don't have any data to work off of other than what we see along the Wasatch Front. And we're dealing with the whole new variable of growth that is so rapid. It just presents many new challenges, and so we don't have old models to go off of, and so we're kind of reinventing or inventing everything as we go, and we don't really know what the ultimate impact of all that is, and what supplies we're going to have to meet, and what the demand's really going to look like.
Thank you, Chris. It's a really good point. Many of the groups here are working with larger water sources, the Bear River, the Weber River, the Jordan River, Provo River, where we know a lot more about sources. But Chris brings up a good point with small communities that have smaller water sources that they're getting their water from. Go ahead, Con.
Hi, I'm Con Baldwin. I'm a water manager on the Bear River Bear Lake system for Pacific Corp. And one of the important issues for us is just the annual variability. Just a very short, brief example, we had coming out of the drought of the mid-2000s, a very high water year in 2011, which was quite dramatic, and actually we've been living off that for the last couple of years. And so the mean annual flows are very important, and that's the main driver. But especially in a system with storage, like we have at Bear Lake, the variability really makes a big difference. And when you're doing a regression and not capturing that variability, there needs to be some way to re-inject even at a random level, either through resampling or just adding back in random variability to kind of model correctly the infrastructure that we have to take advantage of that variability, so that when we do get a wet year in the midst of this drought years, because 2011 really was kind of the only year that we've had that hasn't been pretty much subnormal, even though it hasn't been, the last few years haven't been drought other than just quite below normal. So I think that's an important thing to consider is the variability and kind of capturing that in modeling our infrastructure and how we are able to manage through drought.
And that what I think what Con is talking about, that might be a spot where if we as research scientists can help the water management community really incorporate some of the paleo drought reconstructions that Justin and his group has been working on. Because I think these are things that many of you have seen for several years now, but I don't know to what degree those have really been fully incorporated into the actual planning process. And I think that's a spot where there is a little bit of a mismatch still between the information that research science creates and the information that's most usable for water agencies. There have been a couple good points about talking about kind of the messaging of climate change and climate variability and how best to talk about that. But I'd like to hear a little bit more about some of the actual uncertainties. I've heard about variability. Are there any other climate uncertainties that we haven't yet touched upon that are important to some of your management? Yes, yes.
So the Google Docs are public note-taking forums. I've noticed I'm the only one who's actually entered stuff, and I'm going to try and add comments that are already made. But anyone can go in, enter stuff, change things that you see misrepresent or misstate what you state. Feel free to jump in. The URL is at the top. So it's just a public community-based note-taking system, essentially.
And to access Weber's wireless network, it's WBW guest, and the password is conserve water. So maybe let's move on to the second question we have on here. Unless, go ahead, please.
Just one comment. I guess in my mind,
Could you say your name?
oh, Scott Paxman with Weber Basin Water.
Thank you.
In my mind, climate is uncertain, and so the question is a little ambiguous, but it's becoming more and more of an issue. We know that the climate variability it's getting worse. I mean, there's more uncertainty to the climate in the last decade or so, and which increases the challenge for the water suppliers to actually understand and predict or forecast what kind of season they're going to have the following year or the following 5 years or whatever. So I don't know. It's all very important, but it's all variable, and so I don't know which is the worst or which is the most important. But it all is important. I don't know.
Go ahead, Bart.
Yeah, Bart Forsyth, Jordan Valley Water Conservancy District. I think from our perspective, you know, what we have facing us is the climate variability issue, and then there's also on top of that, in some respects, the climate change issue, and climate change being perhaps something that's caused by man. And from my perspective, how do they coexist? And so we know from the climate variability studies all the different changes that have happened in the past, and now what we have on top of that is perhaps climate change, and so what's the output at this point? What can we expect? And then as we look down the road, from a water supplier's perspective, you have how does climate variability and change impact our water supply, and then how does climate variability and change affect demand? And one of the big questions that's facing a water district is, do we need to start spending money now to become more resilient? And that's a policy question. And when you have the concern with respect to how much is the climate change science being accepted by the public, it gets really hard to discuss spending money. There are others across the globe that are spending money on climate change already. But for me to go to our board and start asking them to basically appropriate funds to begin spending money on climate change, it gets awfully difficult, especially when it's not widely accepted. And in many cases, it's even hard to sometimes even bring it up in staff meetings because it's not widely accepted. So those are some frustrations and maybe some uncertainties for us.
Thank you, Bart. Does anybody else have any comments on this first question before we move on? All right. Well, one thing that as research scientists looking into water availability in the past and in the future that we think about, and I know that you as water managers think about, is you have a particular drought of record that you have in your mind with your management and how you manage your operations in relation to that drought. We know looking into the past that with some of the information we saw from Justin, say from the Bear River, that some of the droughts of the further past of the paleohistorical record are of much greater length and sometimes intensity than the droughts that we've all seen within the historical record. So it would be helpful to us to have a little bit of a discussion about drought and how do you as water managers define drought and what do you specifically consider your drought of record in your management?
Tracy Kirkham, Salt Lake City. I think that our record of drought is 1934 and 1977. Those are the extreme lowest flows we've had. Would you guys agree? I think you would agree, right?
And do you think of that in planning for that drought, is it just that 1 year event that you're thinking about, or are you thinking about some of the droughts that have been more extended past just the 1 year record low flow event? Like I know Con was kind of alluding to that while the last 4 years haven't been in drought per se, they've all been low flow, and the accumulation of those low flow years, depending upon the water system you have, has different implications.
Well, I think that we have to start planning and implementing things, but like Bart said, like if it's not believed by half of the board staff, I mean, it's really difficult. We need to try to, I mean, I know that climate change is happening as well, but we are the water people. So we need to decide how do we convince our boards and our public to take a new approach, or how do we start the change? How do we start? Who's going to change first? And how are we going to change it? Public, media, I mean, I don't know what to say about convincing the citizens. And so I don't know if that's a bigger project for us for a few years, but I don't know that we have a few years. And so I think that that's important to try to figure out.
Thank you, Tracy.
Can I ask a follow-up question? This is Joanna Interwada. I just want to ask a follow-up question of both of you. Internally, does framing it as risk management or contingency planning make any difference?
I think it does, and I think that's really the approach that Jordan Valley will be taking. And I think from my perspective, I've been given the assignment on behalf of Jordan Valley to do some testing and analysis and coming up with a long-term plan for Jordan Valley Water. And I think the contingency planning is the way to go. And I think basically what I'm going to be doing is trying to identify mileposts, if you will, down the road. If this starts to happen, this is what we need to do, and be prepared to do these things. Prepared to implement some things as we move down the road. I don't know exactly what's happening now, whether this is a short-term thing or a long-term thing, but here in our area, in the Salt Lake International Airport, we're seeing increased temperatures. And we're seeing increased temperatures early and late in the year on the shoulder seasons, which are impacting the way snow is melting and the way demands are happening. And so from my perspective, if this is the long-term trend, it's already happening. And so we're already having to do some things now to offset that. And I think we need to have the plans in place, assuming that this is going to continue. And when we get down a few years from now, if it's continuing to happen, then what are we going to do and what kind of money are we going to spend? That's how I'm going to approach it. But there may be other ways to approach it too.
Scott Paxman with Weber Basin Water. Just a comment to answer your question. Weber Basin operates on the Weber River, and we are the junior water right holder on the Weber River. So the last 5-6 years, 2011 was a great year, like Con said. And the last 4 years have been below normal, as far as below drier than normal. If it wasn't for the spring rains or the fall rains that we had received in a couple of those years, we'd have been in a much, much worse condition. So we have 2 years of actual storage on our system. And so the answer is we can span 2 years. But, it all depends on that variable climate again. And like I said, if it wasn't for those rain events during the times when it typically was dry, we would have been much, much worse. So how do you plan for those? I have no idea. But risk management, I think, or contingency planning is a great way to look at it. I think I think the common or people will accept those sorts of strategies to try to manage the risks that they're well aware of. They know about the droughts. The droughts are very publicized, and so I think just trying to educate the public in the things that we expect to try to span those dry years, drier than normal years, especially those paleo droughts, very, very extreme drought periods. So,
Thank you, Scott. So does anyone else have any other? Go ahead. Could someone pass? Oh, thank you.
One of the things that we have, I'm Rachel Shilton, I'm with the Division of Water Resources, and my background is engineering. One of the things that we have to overcome is that historically, we over-designed. We have enjoyed a surplus of storage and over-design for our water systems in the past. And so our population enjoyed not having to worry about it. Our population has now grown up to the point where we're no longer over-designed. And so when we have those historic events, it is an impact now. And we have to figure out how to educate the public about just that issue, that the reason we haven't had to worry about water during dry years is because we had that excess storage, and we no longer have that. So now it's our job to create storage that is, I don't want to say excess necessarily, but storage that will provide for those future years like we had previously.
I just want to add a little bit to the conversation about how to frame this with boards, or at least toss out an idea that I know the state and the Division of Water Resources focuses on. I'm Kelly Cope, by the way. And that, Rachel, you just brought it to my mind, and that's population growth. I mean, drought is one aspect of this for certain, but population growth is another huge aspect of it that I think people could relate what you've just described in terms of excess storage to more people. We've got more people, and that storage isn't really changing. So, that's pretty simple math to my mind.
Thank you, Kelly. Darren?
So Darren Hess with Weber Basin. Another point I think to bring up is, as we look at our water supplies and our water deliveries, and what Weber Basin up here has a large secondary water system that is unmetered. Historically, we are metering those connections now, but historically they have been unmetered. And as we've looked at our demands, and we've looked at the areas on large meters that are come into some of these other areas, we have seen over the last 3-4 years, as we've had the low water supply, that the drought messaging, people, even though on an individual basis to their home it's unmetered, but they understand the overall drought message, and we've seen a decrease in water deliveries through large meters to big areas, that the demand is decreasing. But as soon as that 1 year comes up that, we're 90% snowpack, rains are off, and open the floodgates again. And it's not, that message that, there's a new normal now. It's not just drought mitigation. I mean, you've got a lot more neighbors, a lot more individuals that we have to think about. And it's not just one good year and open the floodgates. And how do we get that message across to the public that, we can't have that mindset anymore. We need to continue to have this drought mitigation and these, tendencies to always save water in our minds, and we just can't let things go crazy again. So.
That's a good point, Darren, especially thinking about some of the droughts that we see in the paleoclimatic history. If we have a 10 years of maybe not, really extreme low flows, but like Con was mentioning of how it's affected how the last 4 years of relatively low water, and then you have one really good year if the public perception is that, okay, it's a good snow year so we can use as much water as possible, that has some pretty serious implications on then your use of water and of water availability in the coming years if we do have more years of lower flow. I'd like to move on to the final question that we posed. And this gets at some of what Justin and David were talking about, and is really an important question to us as researchers trying to help answer some of these climate questions for water agencies. How does your agency use climate projections and information from paleoclimate reconstructions currently? Does anybody actually use these data in their planning processes more than just kind of in a really general sense?
Hi, Con Baldwin with Pacific Corp. It wasn't for a specific water management need, but for one of my presentations at a Utah Water Users Association conference. I did use, this is predating all of this, in about 2003, 2004, went and used there was some existing tree ring data that was out of the dinosaur, what's it called, that national monument that's in Wyoming, just kind of east of the Bear River. Fossil Butte. So I just used some of that existing data and just kind of did some resampling of historical years based on that, and was able to kind of identify kind of a longer drought period, at least in my period of records, in the late 1800s into the 1900s, when it was a little bit drier. So it was more just of a kind of for kind of informational purposes and for the presentation, but it was fairly interesting to do that kind of an example for that presentation.
Thank you, Con.
Well, as I had mentioned earlier, we've got a 20-year history, so there really isn't, these conversations haven't come up. We don't even know what we're dealing with future water needs. But I can tell you, for me as a policymaker, it's something that I'm very concerned about, whether or not we're going to be able to deliver the needs for the city and all water users moving into the future. And we really don't know what that looks like. And I think if you speak to any policymaker about their role and responsibility to make sure that these resources are available for the existing population, if not for the future population as it grows. Again, moving away from that conversation, that political conversation, and focusing specifically on what the needs are and what variability are we up against. There is no more compelling data out there to help policymakers see the need for accounting for this future variability or climate change than that paleo data, because it's data that's there and it's in front of you. You know exactly where it came from. It's not just a statistical model. It's a statistical model based off of a tree, and you know where the information came from. So I think that's pretty compelling. Again, we don't use it now, but I think that's something that probably needs to be distributed far and wide. Perhaps it already is, but far and wide to the policymakers, because it's a compelling story.
Scott Paxman again. I think we totally acknowledge the information that, yes, it's warmer. It's going to be warmer than normal. We're going to have about the same precipitation, but it's going to be more rain than snow. So I guess we use that, but how do we use it? I don't think we really have yet, but I would be very interested, or we would be very interested in seeing some of those return periods of, how frequently are the severe droughts, and how severe are they, and how long will they persist, and those sorts of things. I think all that information is going to be very useful in the future, but to date I don't think we've used it much.
So we have two sources. One, we have basically the snow melt and precipitation that happens within Cedar Valley itself. That catchment is basically receiving snow melt from the Ochre Mountains and the Lake Mountain Range, but primarily the Ochres. And so that's the majority of it meeting our existing need. However, we also have contracted with CWP. And as the population grows, the majority of the water will be imported, still connected to the same basin, but that water is basically coming out of Provo Canyon and other areas, and it's being delivered from the aquifer on the east side of Utah Lake.
Scott McGettigan, Division of Water Resources for the state. Seth, you asked the question was, are we using paleo records in our current work right now? And I can speak to the Weber River model that we have in our office that I typically manage and control, that we have implemented some triggering flow data from the reconstruction of the Weber River. And you know this, I've worked with you on that. And we're still looking at how to implement that into actual practice and where it might be useful. And so that's one example of where it's being used right now.
Thank you, Scott.
Roger Kelgren, USU. I just want to pose a general question really to the group, and it relates back to both drought and this is temperature. And it's something Simon touched on that I think really is an eye-opening set of data, that we've had the greatest temperature anomaly the past 2 months across the globe. And we've been having much warmer temperatures, and it's actually a discussion with Bart last year when they were starting to see people using water on their landscapes in mid-March, which historically they did not have. And that brings up the question of both paleoclimate and that we can reconstruct temperature and evaporation. We have the tools, we haven't done it yet. And the level of that might be of interest. But also that there is going to be more hot droughts than cold droughts. And it's something that we've looked at a little bit with the dendrochronology group, and that 2000 to 2004 was not really that major of a water drought, but it was a hot drought, and it was off-scale hot. And we're probably going to have more of those. So it's what the perception of the group is about rising temperatures.
Maybe we'll take just a couple comments on that, if anybody has it, before we end this discussion and go on a short break. Does anybody have any responses to Roger's question?
Simon Wang here. I just want to, again, following Roger, post a general comment here. I think everyone in this room, we're here because you want to be proactive. And we know the perception side of the public will take time. Meanwhile, you're all dealing with this variability stuff from short term to long term. And as a meteorologist, I want to point out that the reason we're here and then we begin with paleoclimate data and why this is important. And I've shown you that currently the numerical models, which is based upon the physics, they're not doing as well as we want them to be, but it's not hopeless. For example, El Nino prediction, 10 years ago, up to 10 years ago, the statistical models simply based upon past informations outperforms any numerical models at that time. But now it's not the case. But the numerical models are not outperformed and consistently. They are just in dual now. But what's the projection? The projection would be that the more the computer power, the knowledge, and the observations made in the oceans and the Arctic, then eventually model data can surpass that. Here, right now, in the Western U.S., I can show you tons of examples that so far the weather models that turn into climate models, they're not doing a very good job here. But it's not hopeless here because we're in a very unique regions. And then the mountain system and snowpack system and watershed systems is helping to filter out noise, keeping those climate informations. And Pacific Coast, for example, you mentioned benefit from this the spike of wet years, and then that has been sustaining all the following droughts. So what we can do by looking back is all this variability, how those super wet years that has saved us from the subsequent droughts. Would that happen or not? Did they happen persistently in the past? If they did not, how do we know what is controlling those? How this is suppressed? Those are something only terrain or paleo records can do. So my comment really to summarize that is that we have tools and we're trying to do it. Currently, computer model is the only means you can use to project future in an operational manner. But right now, they are not there yet. They will be, maybe very soon. In the meantime, we have this good tool that look back into the future, which can all continue to assist you in predicting for the future as well. Thank you.
And I think with that, we will end our first discussion. Let's take a 10-minute break and reconvene at 10:35, and we'll start that next section on water conservation off with a short video abstract and 3 presentations.